Hello everyone and welcome to another episode of Stable Diffusion Experimental. Today we'll be looking at a way to integrate Stable Diffusion into Blender or any 3D software really in real time. Now last week we did use Blender and Stable Diffusion together, and I didn't say it was experimental, I did say it was for professional creatives. So why is it experimental now? Well, let's just say that to define this setup as janky would be making it a compliment. Today I'm going to show you two different workflows. You can see them on the right hand side of the screen here. One is with SDXL Lightning and the other one is with Hyper SDXL. Now Hyper SDXL just came out, there's no fine-tuned models for it, it's just the base SDXL model but fine-tuned for generating images with just one step. And that normally would just be jank enough, but everything here relies on a node that is called screen share. Now I've searched far and wide on GitHub for a node that could use the viewport from Blender or from any other 3D app out there, but I couldn't find any. Now some of you may be aware of a custom node that lets us use comfyui like nodes inside of Blender. But one, that would be applicable only to Blender, and two, that node suite is not well suited for what I had in mind, because it's quite restrictive in what can actually be used as nodes inside of Blender. So what I wanted to do was having a comfyui instance running and sourcing images in real time from what I was doing inside of a 3D environment. And the best node I could find was this screen share node. Now, same as usual, we will be building this node structure together, and I will show you and give you the links to download all the custom nodes that we're going to use. But first, let's take a look at what this screen share node does. Basically, the screen share node allows us to share a screen much in the same way you would do during a normal conference call, for example. So if you click on the button, a window will pop up and it will ask you about which screen you would like to share. In my case, that's Blender. And if you select that, you can allow the screen to be shared. And then the window will pop up here inside of the node. Now everything is being captured live, and we can also set an area. So in my case, if I want to select just a tiny square area inside of my Blender workspace, we could do that, and then we would be loading the image directly from the screen. Now normally this would be great, amazing even, but the thing is that screen grabbing live consumes a ton of resources. And when you're adding those resources on top of Blender and on top of comfyui as well, and in my case on top of OBS for recording and my camera, then the setup becomes a lot jankier than usual. And that brings us to the question as to why I am providing you with two different workflows. Well, at first I was testing this with SDXL Lightning, which requires between 4 and 8 steps of inference. But while I was testing it, SDXL Hyper came out, and that only requires one step. So I wanted to show you the difference between a fine-tuned SDXL Lightning model that requires a bit more steps and the base model for SDXL Hyper. So now let's build the workflow from scratch. And if you want to jump ahead and see the actual testing, you can go ahead and skip all the building process. Same as always, you can find the workflows in the description below, so if you want to just test it out yourself, you can just download the files and have your way with it. So the first thing that we're going to need is a suite of nodes called Mixlab. This is a suite of nodes that has a lot of different nodes in it, but what we want to use is the real-time design nodes with its screen share node. Unfortunately, we have to install all of it. So what we want to do is just go over to the green code button here, copy the GitHub link, and then go over to our comfyui folder, double click on it, search for custom nodes, double click on it, right click, open in terminal, and then type git clone and paste the link to the repository and then press enter. Now in my case it already exists, so it threw an error, but in your case it will install all of the nodes. Then we're going to go searching for the comfyui Mixlab nodes folder inside of our custom nodes folder, double click on that, right click again, open in terminal, and then write pip install -r requirements.txt -user, and then press enter. And if everything goes correctly, it will install all of the dependencies that you were missing. then the next thing we're going to need is an SDXL Lightning or the SDXL Hyper models. Let's start with the Lightning version. For the Lightning version, you can use a fine-tuned model, just like Juggernaut XL Lightning. You can go ahead and download it, and then you can see here that you have the actual settings for the K-sampler that you're going to use for this SDXL Lightning model. So in our case, that's between 4 and 6 steps, with CFG between 1 and 2, a sampler is TPM++ STE, and if you want to use this model, you're going to need to remember those, because those are the ideal settings. And then if we want to use Hyper instead, we're going to go over to this Hugging Face page. It goes as slow as just one inference step, and it's very, very fast. Now, the downside is that it's not a fine-tuned model like Juggernaut is, so it doesn't give the best results. Now, if we go down in the page, we can see that there's some settings for the comfyui usage. We can use it with either SDXL or SD1.5, and there's also a text-to-image workflow if we want to use that as well, just for starting. So let's grab this workflow, which is in JSON form. You can click on raw and then download it as a JSON, or you can copy and paste it in like Visual Studio Code, for example, and then save it as a JSON. Then let's go over to Files and Versions and download the safe tensor for the one-step SDXL unit. Now there's two different models, one that is 10 GB and one that is 6.94. We want the one with comfyui written on it, so that's the 6.94 GB. We're going to download that and place it in our models checkpoint folder inside of comfyui. And while the safe tensor file downloads, we're going to drag and drop the JSON file for the workflow that they provided inside of a comfyui instance, and we are greeted with this node tree. Now, in your case, you're going to be missing some nodes, so what we want to do is just go over to the manager and then install missing custom nodes. Here I'm not seeing anything because I already installed them, but you're going to see just a suite of nodes, and you're going to install it, and then you're going to have all the nodes you need. Now let's take a look at the nodes that they left here. So to use the Hyper SDXL unit for one-step inference, it requires the Hyper SDXL one-step unit scheduler, and that denoises from 800 steps rather than 999. Now what does that mean to you? Basically nothing. What it means is that the model has to go through this node over here, and this node takes care of everything. But in order to use this node, we have to use a custom K-sampler node. Now, a custom K-sampler node is basically the same as the usual K-sampler node, but it's just customizable with some things that are not customizable in the usual K-sampler node. In our case, that's a sampler node and a Sigmas node. The K-sampler node basically does the same as the sampler window that you had over here in the basic K-sampler node, and the Sigmas node takes care of all those denoising calculations that are present here in the nodes. So now that we have everything that we need out of the way, we can start building our actual workflows. Since we already have an example workflow for Hyper SDXL here with us, we can just start by switching things up over here. So we already know that the basic structure of the K-sampler must be the same as this one. So we're gonna leave it just like that. I am just gonna rearrange the windows a bit so that it looks a bit more tidy. I'm gonna delete this node, and then we're gonna start actually building. So the model that we actually wanna use in the load checkpoint node is the Hyper SDXL one-step unit comfyui. We are going to select that, and then let's think about what we actually need. We want to grab an image from our screen that will allow us to use our viewport in Blender or any other 3D program and use that as reference for our generations. So we don't need an empty latent image. What we need instead is an image that gets encoded, and that image comes from our screen share node. So we're going to search for that and add it over here. Another thing that we're going to need is a resize image node, because we are not entirely sure about the dimensions of the image that has been screen shared. So we're going to search for a resize node, put it right over here, and connect the image output from the screen share node into the image resize node. We're going to select 1024 by 1024, since this is an SDXL model. And then what are we going to need? So we want to keep the overall structure of the composition inside of our 3D program, so we want to use a combination of control nets. Now, remember that everything that we are adding here adds resources that are needed in order to do all the calculations, so we want to be as lightweight as possible. We could be using a different combination of different control nets, such as open pose, depth, canny, or anything really. But I find in my testing that the minimum amount of control nets that we want is 1 basically, and that's depth. And then if we want to add more, we can do that by adding open pose or canny or whatever. But for starters, let's start with depth. So what we want to do is search for apply control net, drag and drop from control net, and search for control net loader. Here we're going to select a light depth model, and then we are going to run the image from image resize through a depth estimator. So in our case that can be Zoe or depth anything. I'm going to go for the latter. I'm going to connect the image output from the image resize node into the depth anything node, and then the output from the depth anything node into the apply control net node. Now what I usually do is just add a couple of preview image nodes just to see what images are being grabbed and just troubleshoot in a way what's happening during the process. So I'm going to drag and drop from the image resize image output and search for preview image, place it right over here. And then I'm going to do the same from the depth anything output. These two nodes will give us an estimate of the preview image that we're getting and is being resized, and the preview image of the depth that is being calculated. Then we're going to run our positive conditioning through our apply control net node, and then we're going to connect the conditioning output from the apply control net node into our sampler custom node. And that's basically it. The only thing that we're missing is an actual starting image from which we're working. So what we're going to do is we're going to encode the resized image from our screen share node into a latent. So we're going to search for a VAE encode node, link up the output from the image resize node to the VAE encode node, link up the VAE from our checkpoint, and then link up the latent output to the latent image input inside of the K-sampler. And that's it, our workflow for Hyper SDXL is complete. But before running it, let's do the same, but with SDXL Lightning instead. Now, if we want to use SDXL Lightning instead of Hyper, what we can do is just delete all the sampler custom nodes that are related to the Hyper SDXL instance. So in our case, that's sampler custom, that's K-sampler select, and Hyper SDXL one-step unit scheduler. I'm going to select them and delete them. And I'm going to search for our regular K-sampler node. I'm going to place it right over here. I'm going to connect the model output from the load checkpoint node into the model input in the K-sampler. And then I'm going to connect the positive conditioning coming out of the control net into the positive input in the K-sampler, the negative prompt into the negative input in the K-sampler, and then our latent. Next, I'm going to connect the latent output from the K-sampler into the samplers input into our VAE decode node. Then I'm going to select our SDXL Lightning model, in our case that Juggernaut XL V9 Lightning, and then I'm going to set all the parameters here in the K-sampler. So in our case, that's between 4 and 6 steps. If you remember from before, I'm going to put 4. A CFG between 1 and 2, so let's say 1.3. For sampler, we want DPM++ sampler, so let's say DPM++ 2MSDE. And for scheduler, we want to select SGM uniform. And that's it, we got both workflows up and running. Now what we're going to need is a scene set in Blender and then a prompt that actually describes the scene that we're trying to reproduce inside of comfyui. So I'm going to open Blender, and here we can have the scene that we set up last week in our Blender to comfyui workflow. It's basically the same. I'm using a mixamo character with an animation of the character standing up and kneeling down. And if you want to see how I set that up, you can go back and watch that video as well. What we basically did is just we grabbed a mixamo character and an animation from Mixamo, and then downloaded the FBX, and then set up a whole scene inside of Blender. Now, a thing that is very important here is to set up the scene so that it's being rendered with cycles instead of Eevee. We don't want the normal viewport without shaders. We want our actual render view, and we're going to go over to our render settings inside of the scene, inside of the viewport, and we're going to select cycles here. If your hardware is struggling a bit with keeping up with all the samples that are needed for a scene, you can just lower here the samples that are being rendered inside of the viewport. But why do we need cycles? Well, that's because as a source image, it works better if we have actual volumetric lighting. Now for testing, let's start with the SDXL Lightning workflow. I've already set up a positive prompt that describes the scene that I'm trying to get. It is a cinematic photo of a battle-worn knight kneeling in a temple in front of a globe emanating light. We can see that we have all those elements in our blended scene over here. We have the overall structure of the runes, we have the knight kneeling down here, we have the orb glowing with light. Now what I want to do is click on the share screen button here in the screen share node. I'm going to select Blender and then I'm going to click on allow. I am going to set the area, I already set it. You can try and set it to as close a square as possible, because you cannot set up a fixed square area by default, but if you go like close enough, that's enough. And then I'm gonna click on live run. Now the way that this is all set up and the screen share node works is that you don't have to actually hit Q prompt. Instead, every time that something changes inside of Blender, let's say you switch your camera view or you click on some things instead of others, the live feed from the screen share node refreshes and it uses that as a new load image. And as you can see, we keep getting new images here in the preview image node. We can just try to move around the camera, and once it's done refreshing and generating the previous image, it's gonna start again and generate a new image. So this one is from the previous view, and the one that's coming up right now is going to be from the view right now. Now, why was I telling you before about using cycles? Is reflected here in this image in particular. You can see that the globe here is not present in our generated image. And that's because the loaded image from the screen share is not detailed enough to see some changes in the lighting. In our case, the globe and the ring in the background, they're both emanating light, and the difference in contrast is not high enough for our depth anything node to pick up the difference. So it's not being reflected actually in our generated image. So we want to have this globe of light either shining a bit more than the background, or we can just place it, let's say over here. And you can say that there's a difference now. Since the globe is in front of something that has a different depth and different lighting, then it gets picked up by the actual depth anything node. Now keep in mind that this is slower than normal because I am both using Blender and Stable Diffusion, but I'm also recording myself doing this. But still, it's quite fast. And this is not top-notch equipment. I mean, it's very good equipment, but it's nothing crazy like a 4090. I only have a 3080 Ti. Now, if we wanted to add a node that we already know from our Photoshop to comfyui experiences, what we can do is just drag and drop from the image output from the VAE decode node and search for Popup. You're going to find a link to the Popup node as well in the description below. If you want to see how that works, you can go back and watch some of my Photoshop to comfyui videos. But what this does is basically creates a pop-up that then can be fixed in position inside of another environment. Let me show you that, because it's a lot easier to understand if I show you. So I'm going to move the image around. The generations are going to commence, and then a pop-up will be created here on the window. What we can do now is just resize it a bit, and then pin it in a place where it's not obstructing anything. So let's say I'm going to put it right over here. Now I'm showing both the comfyui instance on the right and the Blender instance on the left, but that's only because I have to show you the workflow as well. But if you wanted to maximize the Blender window, for example, you can just keep the comfyui workflow working in the background and then have just the Popup Preview inside of the Blender instance, for example. And that's quite good to just preview the images that you're rendering while you're working inside Blender. So now let's close this pop-up. I am going to stop the generations here from the screen share, and let's go over to our SDXL Hyper workflow. So I'm using the same exact prompt as before, but the node tree is going to be a bit different because I am using the Hyper SDXL version. Same as before, I'm only using depth as a control net because I want this to be as lightweight as possible. And I'm going to click on share screen. I'm going to select Blender again, allow, and then I'm going to set the area here in the center of the viewport, and I'm going to click on live run. Now here, as you can see, it's picking up the image from the viewport, it is picking up the depth, and then it is generating the image. The The quality of the image is nothing close to the fine-tuned model, in our case, Juggernaut, but it is a bit faster because it's only taking 1 inference step instead of 4. Now let's add a Popup Preview node. I am going to maximize my Blender screen, and I'm going to reset the active area, because changing the proportions of the window and maximizing it changes the actual active area of the screen share node. I'm going to hit on live run. I'm going to minimize the comfyui workflow. And here we have our actual viewport with everything that's happening inside of composition and the generation here appearing in the pop-up on the left. Now we can work on the image in real time, and then it will get updated inside of our pop-up in something that kind of resembles real time. And this is all with just 1 inference step by using Hyper SDXL. Now, in order to get better anatomy, we could add an open pose control net, but that would slow things down a bit. Depending on your hardware, you can do that. But yeah, let's say we wanted to add some columns. So I'm gonna look for a cylinder. Gonna place it, gonna resize it, adding it right over here, duplicating it. We can see how these things get implemented in our generations. Let's say I wanted to resize the glowing orb and maybe tone down the light a bit. We can see that the scene changes in close to real time. To me, this is amazing. Let's say I wanted to switch to the SDXL Lightning version. I'm just going to select again the Blender instance. I'm going to set the area. I'm going to hit live run, and there we go. We get a much better image, much more refined, because we're using SDXL Lightning now. And even if it's a little slower, it is very nice. And this has its uses. We don't need to use shaders. We don't need to build materials. We can just use Blender or any other 3D programs as a source of composition. We can just use basic shapes in order to create complex environments. This is not refined, yes, but at least it gives us a way to control things even without any actual abilities in the medium. I haven't used anything that you cannot learn in half a day, basically. I have only used basic shapes, cubes, cylinders, spheres, and basic materials such as a white material over here and an emission material over here. Even the human figure is just downloaded, as well as the animation, from Mixamo. So all in all, I think this is as amazing as is janky. It's a great implementation in order to get rough ideas and start from scratch and get good composite results. And it shows that we can have a great degree of control over how a final image is actually generated if we implement already existing tool in our new medium. Even if this does not substitute the need for renders and render engines and materials or shaders, it is a side grade of sorts, because getting materials and shaders that are good enough for compositions and just for allowing the clients to actually get a feel of what we're trying to do is oftentimes cumbersome and time consuming, whereas this way we can just generate stuff in a matter of seconds that actually resembles what we want to do. Now I can already hear the architects among you saying that this is not good enough for them because they want to be able to show the clients actual materials, the real stuff that they're going to use. But I believe that taking this from a different perspective, from a previous stage, can have its uses. And for those of you that are doing concept arts or are doing image research for new projects, then I think this is actually invaluable because it allows you to set the scene and then just forget about everything else that you were used to do in a 3D environment. Yes, you are trading precision, but you're trading that for close to instant generations. So that's gonna be all for today. I am actually quite happy that we managed to do a real-time implementation of the previous week's process. I hope you liked this video and had fun and learned something new. If you liked this video, please leave a like and subscribe. My name is Andrea Baioni. You can find me on Instagram at risunobushi or on the web at andreabaioni.com. And same as always, I will be seeing you next week.